This is 1.29. A sample of tetrachloroethylene, a liquid used in dry cleaning that is being phased out because of its potential to cause cancer, has a mass of, so mass is equal to 40.55 grams, and a volume of 25 milliliters. So volume equals 25.0 milliliters. Notice my limiting number of sig figs is my milliliters because there's only 3 sig figs in that number. At 25 degrees Celsius, what is the density at this temperature? Will tetrachloroethylene float on water's materials that are less dense than water will float? Okay, so I have density is equal to mass divided by volume. And so to find the density, I would take my mass, 40.55 grams, and divide it by my volume, which is 25.0 milliliters. Do that on my calculator, and I end up with 1.62 grams per milliliter. And remember, milliliters and cubic centimeters are the same thing and can be used interchangeably. And so this right here is the density of tetrachloroethane. If you didn't know it, water at 25 degrees Celsius has a density of 1.00 gram per milliliter. Water changes density a little bit based on its temperature, and of course when it turns to ice, ice is much less denser than liquid water. Well, not much, but somewhat. That's why ice floats on water. And so since this is a larger number than water's density, this would sink. Letter B, carbon dioxide is a gas at room temperature and pressure. However, carbon dioxide can be put under pressure to become a supercritical fluid that is a much safer dry cleaning agent than tetrachloroethylene. At a certain pressure, the density of supercritical CO2 is, so our density is equal to 0.469 gram per cubic centimeter, or remember, a cubic centimeter and a milliliter are interchangeable. They're the same thing. What is the mass of a 25 milliliter sample? Whoops, 25.0. I forgot the number of sig figs there. 3 sig figs in this, 3 sig figs in this, so we should end up with 3 sig figs in our answer of supercritical CO2 at this pressure. So mass is equal to density times volume. So mass is equal to density times volume, and our density is 0.469 gram per milliliter. And then we have 25 milliliters. The milliliters cancel with the milliliters. Multiply those two together and we'll have a mass of 11.7 grams of supercritical CO2. That's 29.